Good morning, everybody. Yeah, firstly, thank you for coming to the conference today, and welcome to Unity as well. We're very proud to give you have the opportunity to host the conference today and tomorrow, and looking forward to catching up with as many people as I can during the next couple of days. Bit of background about me, who this board person is at the front. So I've been working in sort of games and real-time technology for over 20 years. And I've been working at Unity for 10 of the last 14 of those years. And so I've got a lot of experience sort of working in working with technical development groups and sort of helping to solve people's problems and so on. I have a particular interest in AI. I went to work for a startup company looking at detection of toxicity in online groups and so on, which was a great experience, but the technology wasn't quite there at the time. But I think it's got better since then. And I also got a particular interest in XR and sort of visualization projects and so on. As I say, I've been working in games for over 20 years, and I met my wife playing Asteroids a long time ago. So I'd like to introduce our speakers today. So first up is Richard Scott, who's going to be talking to us about, he's an expert in digital construction, digital twins, and mental health advocates. But just to give you some details, there's Richard, obviously you can talk about that in a minute. But in terms of general sort of process during the day, that there will be, at the end of this particular session, there's a Q&A session, like a panel discussion. And so there will be QR codes that come up on the screen. So if you have any questions that occur to you during the sessions, please scan the QR code, select the AI section within the list of the topics that's in there, and then enter the questions that you've got. So through the wonders of technology, we'll then be able to run through the different questions, and we can condense everything together at the end. So I won't hold you up anymore. So thank you, Richard, and looking forward to hearing what you have to say. I don't know about that. I think you may have to step through the slides, I'm afraid. Sorry. I think you've got to click somewhere. Is there a clicker somewhere? We have one just now, didn't we? Unless, hang on. It's not there. Let's present a cam. Okay. Well,
no worries. We'll step through.
Okay, thank you. Sorry about that. Okay.
Okay, hello everybody. Thank you for staying on for an extra session of AI. I think that Ant has done a fantastic job in sort of setting the scene. I'm going to be talking to you today a little bit more specifically about AI and how it can be applied to our industry. But in terms of the presentation format, we're just going to be spending a little bit of time looking at the history of AI, looking at how it evolved with some very specific use cases and some very specific examples. In the second, following that, we'll have a little look at the underlying technologies that power AI. So we'll get a little bit deeper, not too deep. I'm not a data scientist, just like Ant isn't, but just explain some of those concepts. And then we're going to turn AI lens to our industry. So we're going to have a little look at digital twins, what a digital twin is, what it means, how it compounds lots of different types of data, and what AI can offer to digital twins in the future, and what the built environment could look like. So it's a little bit of future gazing. I hope you enjoy it. I hope you find it interesting. We'll kick in. So have you ever thought to yourself, I can see a pattern emerging here. I'm sure everybody has. Thank you, Ian. Great. Have you ever thought to yourself, I can see a pattern emerging here? Everybody has, right? There's a kind of intelligence, natural intelligence that we have. We have a neural network in our heads. We can interpret and we can infer, and we can kind of get a feel for what's going on. And essentially, that's what AI is. Any type of AI, any type of format, whichever way you're looking at it, it's essentially a very powerful way to recognize patterns. And I'm going to explain a little bit more about that and what it can mean for our industry. Let's start with the history. Let's go back in time a little bit and just take the timeline. 1956 was when AI term was first coined by the group of people at Dartford conference in the US. And they were proposing that the proposal to introduce the idea that every feature of intelligence can, in principle, be so precisely defined that a machine can simulate it. So 1956, that's the start of this journey. And quite interesting, actually, because a couple of years earlier than that, Turing created the Turing test. which was, can a machine imitate a human being to such a degree that the human being can't tell it's talking to a machine? So it's kind of interesting that even before AI was termed, people were thinking about interoperability with machines. So I think it's something that's fascinated sort of human beings for a very, very long time. Let's move forward a little bit. So early 1960s, the very sort of early R&D of AI. What kinds of things were we seeing? And there's going to be a bit of a pattern coming through here, and I hope we will begin to recognize it before we get to the end there. So we had something called ELIZA, which was the first chatbot of its time. So everybody talks about OpenAI being able to talk to computers. We first saw that in the early 60s, ELIZA. It was a rules-based system. So this was a type of AI. Rules and expert-based systems were very early types of AI. They weren't really that intelligent, but it involved essentially describing, using logic and, if then else statements, every possible scenario that somebody could imagine about an interaction on a particular subject with certain types of data. So it wasn't totally intelligent. It was more a type of a simulation. We also had around within that decade, something called perceptron, which is incredible for its time. This was the first machine-trained image recognition system. So this was the first use of a neural network. And we'll talk about neural networks a little bit later on. It was a very primitive neural network, but it worked. It was trained with data. So it was trained with pictures of male subjects and pictures of female subjects. And it was reinforced training, and it was told what a female looked like, what a male looked like, and so on. And over time, it was able to accurately determine what it was seeing, whether it was seeing a male subject or whether it was seeing a female subject. It was an example of a neural network, and it involved computer vision very, very early. And I think the other thing I just want to chat about here, which is kind of interesting and a theme that you'll see all the way through, is natural language processing. So ELIZA was its natural language processing. So we have been fascinated with this idea of humans interfacing with machines in a very natural language. And if any of you use ChatGPT or ChatGPT 4.0 that Ant showed earlier on, that's now a reality. Let's move forward into the 70s. What we started to see here was the adoption of AI-based technologies into industry and the very first industrial robots on production lines. Now, the robots themselves, are they AIs? Maybe not, but is the underlying technology that's making them intelligent enough to deal with things and move things and avoid obstacles? Is that AI? At the time, yes, it was. So the Unimate was the very first industrial robot on an automotive production line. We also had the very first chess computer. Did anybody have one of these? Chess Challenger in the room? Somebody? Yeah? Anybody else? No, the very first chess computer. Again, a rules-based system. It had every possible parameter and pattern that a chess player could make. It wasn't really intelligent. It was following predetermined patterns, but it was it was beginning to put AI into the home. And we had the first walk-in robot called Wobot 1. So we see robotics coming into the scene and a continuation of this rules and expert-based systems. Moving into the 80s, more robotics, but generally moving into the home. This RBX5 was the first sort of general domestic robot. Looks a little bit like R2-D2, came out about the same time as Star Wars. I'm sure there's a little bit of inspiration that was going on there. We had the XCon. Anybody remember digital VAX supercomputers? Hands up. Nobody else ever had a VAX in front of them? I'm sure you guys did. There was a rules-based system that was developed by Digital that allowed them to configure a VAX supercomputer based on the utility that you wanted to create from it. So it was the ability to say, make a suggestion, make a prediction for the best possible outcome based upon what this user wants. Really important kind of idea. And Speak and Spell. People must remember Speak and Spell. I can still remember Speak and Spell. It was the first consumer-grade piece of electronics to have speech synthesis. So this whole idea about interacting and talking with computers is a consistent theme all through the piece. Robotics, natural language processing, still more rules and expert-based systems. 1990s, everybody's going to put their hands up for this one, right? So we saw Clippy, or you might have chose the Wizard, or one of the others in the Microsoft Office suite. Again, a rules, but now beginning to move into sort of machine learning. So Clippy was able to determine, what assistance you might need based upon what it was seeing you were doing within the Microsoft Office suite. So whether you were writing a document or doing a presentation or emails or trying to connect things together, it had some level of intelligence based upon the pattern, and this is important, of interaction that you had with that piece of software. So it was beginning to learn. Very, very early generation machine learning. And it's the first time that we see kind of, machine learning, in a domestic product, well, in a software product that people use day to day. Alvin was the first autonomous land vehicle to use a neural network. So whilst we have sort of Tesla full self drives in America today, which is incredible to watch, this was the very first time that we saw an autonomous vehicle in operation. Using computer vision. So this is the first time on this timeline that I've mentioned computer vision. So sensors attached to this vehicle, observing and understanding the landscape and the surroundings, and making decisions in order to control that vehicle in the interests of safety or the, whatever it was interested in managing and optimizing. And IBM Deep Blue beat a chess grandmaster for the first time. Now, if you ask those people in Stanford back in 1956 if a computer would ever beat a chess grandmaster, they probably would have told you no. But again, I think this kind of re-emphasizes this idea that Ant was bringing in earlier on in terms of the speed of change of technology and its impact. That was really quite an incredible moment, certainly for that grandmaster who was playing chess. Right, you can see his hands in his head in his hands there. Let's move into 2000s, and things start to really pick up in terms of AI. We still have rules and expert-based systems and machine learning. We have robotics. The Roomba was the first vacuum cleaner. What kind of AI did a vacuum cleaner have? Well, it had situational awareness. It understood where it had been, and it knew it needed to go somewhere else in order to finish cleaning the room. So this was a piece of learning equipment using sensors and AI in order to determine the best possible way to clean your carpet or move around your room. Google AdSense, follow the money. I think this is a perfect example of Ant's follow the money. Google want to make sure that you get the most appropriate ads that you're most likely to buy from based upon what you're doing. And Google AdSense did exactly that and did it very successfully and is still doing it today. Maps and navigation. We see Google Maps and we see Apple Maps using computer vision. And you say to yourself, hang on, what's computer vision got to do with navigation? But if you think about the street view, and if you think about the way that the environment is navigated, sometimes you see Google cars on the road with these cameras, yeah? The AI and the computer vision part is stitching together all of those images in a way that makes sense to the human being when they look at it. The street view where you can essentially walk around the street and see these 3D buildings, that's computer vision bringing that together. And of course, maps and navigation are also able to make predictions with regards to how long it's going to take you to get to your particular destination. And it does that using machine learning. Into 2010, and this is where we really start to see some significant change, and change that's going to change the way that the future of AI is moving with deep learning. And we'll talk a little bit more about this in a second. We see Tesla with the full self-drive capabilities in the US at the moment, which is absolutely incredible to watch. If you go to YouTube, look for Tesla full self-drive, you'll see plenty of videos of cars navigating through very difficult situations. Google Lens uses deep learning, this ability to point your camera at anything and for it to understand what it's looking at and for it to give you information about that particular object. Now, it hasn't been trained on every single image in the world, but it's able to determine what it thinks that image is and make a really good recommendation with a high degree of accuracy based upon deep learning capabilities and computer vision. IBM DeepMind beats the world Go master. So we seem to have been obsessed from the outset, I think. Maybe it's just part of the human condition that can a computer be better than a human being? So this whole kind of game AI theme that runs all the way through this, can we beat human beings, continued with Go. And Go apparently is about a Google times more complicated than chess in terms of the number of parameters that that particular game can play out. The person that IBM DeepMind beat didn't think it was a game that followed patterns. He felt that it was something that was so innate to the human condition that he felt his way through this game. And to be beaten by a computer that was trained using deep learning was quite a thing for that person. And more robotics. Boston Dynamics Spot the Dogs. Very, very kind of familiar to the industrial, to the construction space. You see them at Digital Construction regularly walking around the floor, begin to make the scene, begin to come onto the scene. And 2020s, AI is everywhere, and it is everywhere. We have OpenAI from ChatGPT. We have the new model that's come out just last week, which is multimodal, which Ant was showing us earlier on with a great video of helping a blind person essentially see, in inverted commas. That's using computer vision and deep learning. We have development in robotics. We have the Tesla Optimus. Again, Ant talked about that a little bit earlier on. An intelligent humanoid robot to do sort of domestic tasks. We continue to have this natural language processing. So this whole idea that humans are interacting in a very familiar way using human language with the computer is really important. Machine learning still exists, but it's beginning to, but the rules and expert-based systems are beginning to phase out. What you see here, this deep learning phase, is the phase that's going to make the most significant difference to the future of AI and how we operate it. And you can see that rules and expert systems are beginning to fade away. So you see a general evolution of the underlying technologies powering AI and how they've played out in domestic environments. So let's just talk a little bit more about these underlying AI concepts and what they are. We won't go too deep, but just enough to give you an idea in terms of what we're talking about. We leave the expert systems and the rules-based systems behind. I talked a little bit about them before. They essentially kind of model in all the possibilities ahead of time. Machine learning is trained to learn from structured, labeled data sets. Now, this idea of training is consistent across AI generally, whether it's a human training the AI or an AI training the AI. Both are around today. And it's trained to identify patterns. So it's looking for patterns within this data in order to make decisions with a minimum amount of interaction using algorithms. So machine learning doesn't use neural networks, and neural networks are what power deep learning, and neural networks are what make a significant difference to the power and capability of AI. Deep learning is trained from massive unstructured data sets to identify complex patterns and relationships using a neural network. So ChatGPT is a natural language processing AI that uses deep learning that looks for patterns and understanding of words. It's been trained on pretty much all the available text on the internet. And I'm no data scientist, but I have some sort of basic idea about some of these patterns. It's kind of interesting, all right? There's a pattern in a cookbook relating to bakery, right? You will find patterns of words in those subjects that will include temperature, minutes, and oven, for instance, right? Those patterns of words relate to cooking. Now that gives you a very, very lightweight understanding of what ChatGPT is doing in the background. Huge amounts of training to understand the nuance and the relevance of words and bring them together in a way that it can understand and continue a prompt. Is really, really quite special. And we'll talk a little bit more about that in a second. But deep learning uses a neural network and it makes it something very, very different. Natural language processing enables computers to understand, interpret, and generate human language. We've seen this through some of the products that I've spoken about. Computer vision uses a combination of machine learning and deep learning, and it's trained to learn from labeled images to discover meaningful information from digital photographs, videos, visual inputs using a neural network. Earlier on, I talked about this perceptron in the 1950s, right? Pictures of men, pictures of women, many hundreds of these pictures allowed this neural network to begin to understand what a woman looks like, what a man looks like, and make an accurate prediction based upon that particular image. So computer vision is bringing together two different types of AI here. And this is where it gets really, really exciting, because this idea of bringing together different underlying AI technologies is just creating so much synergy and additional power that it's really very, very exciting in terms of where we're going to go. So if you take something like a large language model, which I talked about just a second ago, understanding words, is using deep learning and natural language processing to make that happen. If you think about deep learning, which is looking for patterns, there is something called retrieval augmented generation, which makes deep learning able to work with very specific domain related data. So for instance, within the built environment and digital twins, a deep learning algorithm could work with a RAG system to pull real data from a real operational scenario to add more intelligence to the way that it answers that question. And we'll come on to this in a moment when we start talking about digital twins. A digital twin is a digital representation of an intended or an actual real-world physical product, system, or process. And you often get pictures like this, designed to be effectively indistinguishable from indistinguishable digital counterpart for all practical purposes, including simulation, integration, testing, monitoring, and maintenance. We've seen this many, many times. I've spoken about it often as well. And it's often accompanied with pictures that look a bit like this. So this whole idea that we've got this facility or this building and we understand everything about it, not just what it's made of, what its components are, and what its systems are, but how it's operating on a day-to-day basis by deploying sensory awareness into that building. So we could have air quality monitors within this room, understanding the CO2 levels on this basis that we know if CO2 increases to a certain level, people can't concentrate so well. Should we make that adjustment? We can have proximity sensors so we can understand what is where, occupation sensors to understand who is where. We can have sensors attached to metering to understand energy consumption, to understand water flow, to understand air quality, whatever it happens to be that we measure. We need a lot of data to get to this idea of a digital twin. I'll call it an ocean of data, or many different types of data as well. So let's just think about that. Let's just think for a minute about what kind of information goes into making a digital twin, what kind of data is within it, and then let's think about how we can apply AI to that particular scenario to create more intelligent buildings. Digital twins essentially bring together two very distinct types of data. Static data that doesn't change minute to minute, hour to hour, that's relatively static, like the components in this building, like the specification of this lighting system that we have here. That's not going to change tomorrow or the day after or next week. It brings together documentation in relation to specifications, technical information about the boiler systems or the heating systems, the air conditioning systems in the building. It brings together asset information. It brings together visual information, maybe point clouds or scans or camera images. It can bring together O&M manuals. Information that's relevant, important, describes a building, but doesn't change minute to minute, day to day. A digital twin brings another dimension to that data in terms of dynamic data to understand the operation of that building. And that's done in a number of ways, often by connecting into the building management system, which is controlling all of the high consuming electricity systems, heating, lighting, and ventilation, air conditioning. BMSs provide that information connected to sensors behind the scenes. Retrofitting IoT into buildings to allow us to make older legacy buildings smarter and understand their operation is something that is being done. Powered by high bandwidth mobile networks, which allow the communication of that data effectively. Dynamic data like energy consumption, people movement, and environment. So we've got a huge amount of information there. Static data, as we've talked about, building geometry, documents, asset information, reality capture, O&Ms, dynamic data, BMS, IoT, energy, people, and environment. Lots of data, huge amounts of data, all interrelated in some way because it's all to do with the operation and performance of a building or facility. But how do you begin to make sense of that so that you can speak to the important aspects, the real whys, which are how do we make this building safe, sustainable, performant, compliant, and risk-free? This is ultimately what we're looking to achieve here. I would put it to you that the only way to achieve this and the best way to take value out of a digital twin now and into the future is to use AI. Coupling AIs to digital twins is a paradigm shift that is going to create huge amounts of value. So we have this digital twin hybrid data ocean, static and dynamic data. We can use machine learning, deep learning, and retrieval augmented generation to identify patterns of performance and nuances of patterns inside of that building to understand how it's operating. We can use large language models connecting to this so that human beings can interact with that building in a natural way. So they can ask questions of this building or ask for interventions to be made to this building or changes to be made to the characteristics of this building in a way that satisfies the requirements or the outcome that they're looking to achieve. I believe that in the future, the most powerful change in the AOC space is going to be the combination of digital twins and AI, particularly large language models for human interaction and deep learning to understand the patterns in the data that we see. But ultimately, it's all about being able to create environments that are optimized for the purpose for which they were designed, hospitals that are great places to get better, or schools that are great places to learn, and for the people that occupy them. And having the ability to understand how safe is my building, how sustainable is my building, does my building meet my regulatory compliance, is my building performing as expected, what risks are inherent, and how can they be mitigated. And I think this is the way that we're going to see buildings evolve in the future by combining digital twins and AI. Thank you very much for your time.